Welcome to the wonderful world of heat, temperature, and thermal equilibrium. Make sure you have your guided notes in front of you and a pencil. Let's get started. The standard we're working on today is SC.7.P.11.4. Observe and describe that heat flows in predictable ways, moving from warmer objects to cooler ones until they reach the same temperature. What is heat? Imagine a hot fire on a cold night. As you move closer to the fire, what do you feel? Heat. Heat is what you feel. Heat is defined as the movement of thermal energy from areas of higher temperature to lower temperature. What is temperature? All matter is made up of tiny pieces called particles. Temperature is defined as the average kinetic energy of particles that make up a material. When you add thermal energy to an object, you can change its state of matter. Let's take water for instance. Ice is the frozen state of water. It is the solid state of water. When you heat up ice, it will melt and turn into water. If you continue adding heat, it will evaporate and turn into steam. On the other hand, if you have steam and you cool it down, it will condense into water. If you continue cooling the water, it will freeze into ice. What is thermal equilibrium? Heat moves from warmer to cooler objects until thermal equilibrium is reached. Thermal equilibrium is the average temperature of the objects in a system. Two objects in contact with each other with the same temperature are at equilibrium. To calculate thermal equilibrium, take the average of the components or parts of the system. If the T is 100 degrees and the surrounding air is 24 degrees, the thermal equilibrium is 62 degrees. 100 plus 24 equals 124. Divide that by 2, and that will equal 62. 62 degrees. What is specific heat? Specific heat is the amount of heat it takes to change the temperature of an object by 1 degree. It takes a lot of heat to warm plastic and less heat to warm metal. But why? Well, plastics are insulators and metals are conductors. Conductors are materials through which thermal energy will flow quickly. Insulators are materials through which thermal energy will flow slowly. The cooking utensils in the bottom right corner show us how we can use conductors and insulators. Metal is very durable, so it is a good option to use for cooking utensils. However, when you put it into hot food, it will heat up very quickly and can burn you. All you have to do to prevent this is add an insulator over your conductor. The insulator will prevent you from getting burned while the metal does its job. How does heat travel? Heat always travels from hot objects to cold objects. This can result in a change to the state of matter. Thermal energy can be transferred in 3 ways: conduction, convection, and radiation. In the diagram to the right, we see conduction, where the hand is touching the pot. We see convection, where the hot liquid is rising and the cool liquid is sinking in the pot. And radiation would be the waves of heat that come off of the stove. Conduction is the movement of heat or electricity through material or matter. Solids are good conductors, especially metals. In the picture to the right, the spoon is conducting heat from the hot liquid that is in the cup. Convection, the transfer of thermal energy through a fluid, and a fluid can be a liquid or a gas. Hot, less dense fluids will rise, while cold, more dense fluids will sink. In the illustration to the right, we see water that is in a pot and it is coming to a boil. Heat will rise from the bottom, from the stove, and heat the pot that the water is in. The hot water will then rise and it will lose thermal energy, cool down, and sink. Once it gets back to the bottom, more heat will act on the water. And again, the temperature will rise, the water will rise, it will lose thermal energy, and then sink back down to the bottom of the pot. This can happen for as long as there is a heat source. Radiation, energy transmitted in waves or a stream of particles. This energy can travel through space and any other type of material. In the illustration, we see radiation traveling in waves through space to the Earth from the sun. Here are some examples of conduction. Be sure to write down each example in your guided notes. Touching a metal spoon in a cup of hot liquid. Putting a heating pad on your back. Feeling the heat from a hot poker in a fireplace. In each of these examples, there is direct contact between two objects, and heat will flow from the warmer object to the colder object. Here are some examples of convection, where hot things will rise up and cold things will sink down. Macaroni rising and falling in a pot of boiling water. A lava lamp rising and sinking. Hot magma rising in the mantle, cooling down and sinking. In our next unit, we will talk more about the Earth, its layers, and how the hot magma in the mantle is constantly convecting. It has been convecting for billions of years. Here are some examples of radiation, or waves or particles of energy traveling from one place to another. Laying out in the sun at the beach. Holding your hand over a burning match without touching it. Holding your hands over a light bulb. In each of these examples, heat will be transferred through waves. There is no direct contact between the heat source and the object that is being warmed. Now, let's take a minute to stop and reflect. We just learned about conduction convection, and radiation. You now have to come up with 2 examples for conduction, convection, and radiation that were not in the notes. Pause the video here to write down your reflections. Hit play when you're ready to move through the practice questions. Are you ready for the practice questions? Let's go. Where'd it go? We are going to look at how the heat travels in each of these situations. At the beach on a hot summer day, you drink some ice cold lemonade. Refreshing. Describe the heat transfer that occurs between the lemonade and the air outside. Pause the video here, write down your answer, and click play when you're ready to check your work. All right, let's check your answer. Did you say that heat travels from the hot air to the cold lemonade and that the lemonade warms up? If so, congratulations. If not, womp womp. Go back over your notes before you attempt the next set of problems. I want to make sure that we are getting the information. All right, here's the next practice problem. Describe how heat flows in the image to the right. Pause the video here, write down your answer, and then click play in order to check your work. All right, let's check those answers. Did you say that heat travels from the flames to the grill grates and warms the hot dogs? If so, good job. Let's have another practice problem. David drinks a glass of water in his kitchen. The water is at room temperature, and David decides to make it colder by adding ice. Which of the following describes why the ice will melt? Pause the video here, select your answer, and write down the entire answer, not just the letter, in your guided notes. Click play to check your answer. Did you say that heat from the water moves to the ice? If so, good job. Let's look at question number 4. In the house modeled in the picture, where does the heat flow? What will the temperature be when the house is at thermal equilibrium? Remember, heat will always flow from hotter areas to colder areas. Where will the heat flow? Pause the video here, write down your answer, and click play when you're ready to check it. The heat will flow from room 1 to rooms 2 and 3. We see that room 1 is 27 degrees. Room 2 is 24 degrees. Room 3 is 22 degrees. The energy or the heat will flow from the warmer room to the 2 colder rooms. The average temperature will be 25 degrees. So at thermal equilibrium, the temperature will be 25 degrees. All right, we're almost done. Jeffrey brings a book from the air-conditioned apartment to a balcony on a hot summer day. How will the cool book interact with the outside air? Pause the video here, write down your entire answer choice, and click play when you're ready to check your work. All right, let's see what the answer is. Did you select B? I sure hope so. All right, last question. A 100-degree knife is used to cut cold 20-degree butter. Which statement describes thermal equilibrium in this situation? Pause the video here, calculate thermal equilibrium, and select your correct answer. Hit play when you're ready to check your answer. All right, let's check our answers. Did you say A? A is the correct answer? If so, wonderful. Good job. I sure hope that you got all of these practice questions correct. Para español, go to the next slide. Problema número 6 está aquí. The answer is A. I hope you've enjoyed these virtual video notes.